Hello Physical Science, this is Mr. B. We're going to start, probably finish up section 2 today. The title of this section is Work in Machines. So we're going to take a look at how work, again, force applied over a distance in the direction of motion, is related to things that are known as machines. So all cars come equipped with simple machines designed to make changing a tire a fairly easy task. So if you've ever had a flat tire, notice there's a jack and a couple other tools there to help you change their tire. And those are all what are known as simple machines, which we'll focus on more in subsequent chapters here, or probably subsequent sections within this chapter. So now we're just going to get a brief introduction of what machines actually do and how they can help us. So first main definition here is a machine is a device that will change a force. So a machine is a device that changes a force, and they can do that in multiple ways. So this whole slide is really important. So I definitely make sure you had these things written down. Machines make work easier to do. They can change the size of a force needed, they can change the direction of a force, or the distance over which a force acts. So machines can really help us out when we talk about changing the type of force, again, maybe making a little bit less force than we would need, make jobs a little bit simpler. So the first one, it says turning the handle allows the man to raise the car. So again, this is just a simple little turn on a little jack, and it's going to allow the man to raise a car that's quite large that he would not be able to do on his own. So each complete rotation of the jack handle, it applies a small force over a large distance. So the small force exerted right here acts on a large distance on this car over there. And then a small force exerted over a large distance can become a large force exerted over a short distance, and each rotation it lifts the car only a very short distance. So he is exerting the force right here, and that is just acting on the very short distance right here to try to raise this car up. And then another thing that a machine can do, it can increase the distance. A rower pulls an oar through a small distance. So if you've ever rowed a boat, that's what they're talking about here. Again, you just have a short little motion of your arms there, just kind of in a circle. And then the end of the oar, however, in the water, moves through a large distance. So it's in the water for a longer period of time than what you're actually moving. The increased travel of the oar through the water requires the rower to exert a greater force. A machine that decreases the distance through which you exert a force increases the amount of force required. And then some machines can change the direction of the applied force. Pulling back on the handle of the oar causes its other end to move in the opposite direction. Machines can change the amount of force and the distance the force acts through, as well as the direction of the force. So these things are going to make a little more sense. I know these are going to be a little bit confusing right now. There's going to be a picture that we're going to see here, and we'll talk about these more in class, but just be familiar with the fact that mainly that machines are able kind of to alter our force by doing different things, by increasing distance and changing direction. If I feel it's important, we'll discuss these more in class to make them a little more clear. And based off those two last things, there are going to be things that are called work input and work output related for a machine. And because of friction, the work done by a machine is always less than the work done on the machine. So you're always going to have to put more in because of friction than what you're actually going to get out. So the oars in a boat acts as machines that increase the distance over which the force acts. So we're only moving, so this is what I was talking about right here. So your arm is only actually moving a little short distance. This blue arrow is the input force. So, so you only do a little bit of work right here, only putting in a little bit of power right here. And then this little blue line is our input distance. And however, if you look, our output force and our output distance are much longer. So if you've ever rowed a boat, and you can see, again, you only move your arms a little bit, but the paddles extend all the way out here into the water. So that's one thing that a machine does. An oar is a machine, and it changes the distance over which the force acts. So we put in a little force at our short force at the beginning, and then our output force is much larger towards the end. So that's kind of what those slides back here were saying, these two. And this is just kind of a way to illustrate it right there. And so the force exerted on a machine is the input force, so what you put into it is the input force, and the distance that the input force acts through is known as the input distance. So that's pretty simple. So our input distance, where was that at on our picture? Right here. So again, the input distance was how far the oars moved initially, right here, how far you actually move them, and our input force is right here. And then the work input equals the input force multiplied by the input distance. So we multiply these two together and we get our work input. So you multiply these two numbers, and that's how much work this rower actually put into the oar right there. And so now skipped one, sorry. And then so for an oar, the input force is the force exerted on the handle, and the input distance is the distance that the handle moves, which we've just said. And the work input is the work done to move the handle. So you moving the handle is how much work you're putting into the system right there, into the machine of the oars. Now kind of on the other half of it, the force exerted by a machine is called the output force. So we go back to our picture. We have our output force right here is this red arrow, the fact that the oar is moving through the water and pushing the boat. And the distance that the output force is exerted through is the output distance, and then the work output of a machine is the output force multiplied by the output distance. So these two slides pretty much saying the same thing right there, just kind of polar opposites of one another. So input force, input distance, output distance, work output, work input. So those are all, again, they're all related to one another, and again, really easily seen here by this illustration here with the oar. Again, the work you're doing right here is right here, and then the work that is being done by the machine, the oar, is out there. And okay. Then the output work of the oars results from the oars pushing against the water, so that the water pushes back against the oars. Although nearly equal, the output work is less than the input work because of friction. All machines use some amount of input work to overcome friction. So if this was a frictionless environment, it'd be a little bit easier to row through there, but you're always going to have to put in a little more work to try to overcome that friction there. And then the only way to increase the work output is to increase the amount of work you put into the machine. You cannot get more work out of the machine than you put into it. So that is a really important thing. So you're never going to get more work out than what you put in. Again, you can try to harness it and change it a little bit to make it a little more effective, but you're never going to get more out than what you put in. So that is it for section 2. Let me know if you have any questions.